Hello and welcome to Problem Solved. I'm IISE's Keith Albertson. Our guest in this episode is Lashawn Boulware. She is a human factors design engineer for the Orion Program at Lockheed Martin Space and a keynote speaker at the Applied Ergonomics Conference March 27th through 30th in New Orleans. We discuss her background as an industrial engineer, the unique ergonomic issues she handles on the Orion spacecraft, and her ties to the conference. And also be sure to check out our interview with the other AEC keynote speaker, Stephen Jenkins, the Director of Safety and Health for Cintas Corporation, and his discussion with IISE's James Swisher. Lashawn, thanks so much for being with us today.
Thank you for having me, Keith. I'm excited to be here and to talk to you guys about myself, I guess. Yeah.
Well, and it's a good chance for us to kind of let people know what's coming at the conference in New Orleans. Let's start out just with a little background. Tell us how you first became interested in industrial engineering as a career and how that steered you into ergonomics.
Yes. Well, I would have to say it started at Taco Bell in a conversation with my aunt. I was working at Taco Bell. I must share that I am from New Orleans, Louisiana. So being able to speak at the conference while it's hosted in New Orleans is a pleasure. And so while I was working at Taco Bell, and it was after Hurricane Katrina, and so I was excited because the wages were higher than they typically were as far as the minimum wage. And I was like, I'm about to turn 16. I'm excited. I may make more than the minimum wage, but I had to wait until my birthday. But I started working at Taco Bell because I wanted to earn my own money. And I'm working there, learning how to make the food. And I'm always trying to figure out how to do it faster and quicker because I didn't like when the customers will look down the line and say, what's taking so long? Why are y'all taking so long with my food? I'm like, well, let me see how I can move faster. So I always try to move the lettuce or the cheese in different positions to see if I can just get to it faster while I'm making the food. And so I'm doing this. I'm not really paying attention to exactly what I'm doing. I'm a junior in high school. I don't know industrial engineering. But as I'm preparing for college and trying to understand what I want to major in, I had a conversation with my aunt because I was working the front counter a lot. And I was like, oh, I'm good with money. I keep track of the money well. I don't have any issues with the register. And she works in accounting. And I was like, well, what about accounting? And she was saying to me, it wouldn't be as much math as I would think it would be. So I might want to look into something else, maybe engineering. And so I go through all the engineerings on Wikipedia. So I looked up mechanical and I'm thinking of stereotypical things of, well, I don't want to work with cars. Look at the civil engineering, the stereotypical, well, I want to work with bridges. And then I got to electrical. I'm like, ooh, computers, TVs, I'm good on that. But I got to industrial engineering and I realized, oh, this is about improving processes and being efficient and not wasting time and energy and things of that nature. So I'm like, that seems broad enough. Let me go into that. And so that was my first introduction into industrial engineering. And just thinking about reflecting back on the things that I did at Taco Bell was industrial engineering, trying to manage my time, improve the processes, but not really knowing that somebody else has already thought through that. But, being a young person, and you think you know all the answers to all the questions.
Yeah. It sounded like you had that mindset from the very start then.
Yes, unknowingly I did.
Well, what steered you then into ergonomics and specifically to Lockheed working on something like the space program? That's a very specific path that you took there.
Yes. So how I got to human factors and ergonomics, again, in college, I was fortunate to have a full scholarship, a full ride that paid for my room and board and things of that nature. But at college, you always want a little spending money on the side, to go to go out and to have clothes and things of that nature. And so I was able to obtain a undergraduate research assistant position working with a PhD on his dissertation. And he was looking at multimodal he was looking at augmented reality for designs of displays, augmented reality displays at the time. And he was implementing it for an excavator cabin. And I didn't know much about excavators, but I thought it would be something cool to do, something different. And I was using a digital human modeling tool called Jack to model the excavator cabin itself to understand the placement of the different displays and understanding how it affects the body. So if I place a display at 6 degrees tilted either direction, how does it affect the neck? How does it affect the lower back? And how much can they see out in front of them to complete their task? Being in this excavator is a big earth moving piece of equipment. And so I'm just doing that work in Jack and understanding how to use the virtual reality, 3D digital human modeling tools. I'm like, I like this. Because again, it falls in line with industrial engineering, improving processes and people and design, but it's from that person aspect. And then most recently, like in the last few years, I realized my purpose is to help people. And I'm doing it through human factors and ergonomic principles and helping people understand how they can work more safely and efficiently in their environments. So that's how I got into human factors. But it took a while to get there. I had 2 or 3 internships that were in supply chain, that were in quality, things I needed to learn about, but I didn't want to learn about. And so once I got that bug in ergonomics, I'm like, okay, this is what I want to do. And before I got to college, a college graduate, a friend of the family told me, if there's anything you want to learn more about, consider getting a graduate degree in it. And I was like, okay, well, I want to learn more about human factors and ergonomics. Well, let me pursue a graduate degree in that. And so I went to Texas A&M to get my master's in industrial engineering with a concentration in human factors and ergonomics, because I just wanted more classes about that. And so once I graduated from Texas A&M in it was 2015, I started working at Michelin in ergonomics as a ergonomist for 3 manufacturing facilities in Greenville, South Carolina. And so that got me into ergonomics and just understanding what it means to apply it in the workplace. But then from there, for me, it was more reactive. We're trying to improve 40-year-old equipment. It's very costly. And I didn't like when I would talk to the operators and the technicians of, okay, these are the issues. These are the ways that we can potentially solve it. And then I'll go talk to the managers and like, ooh, the budget though.
Yeah. That's part of the trick, isn't it? Is getting all the buy-in there. Yeah.
Yes. And so I wanted to be more on the design side to say, well, let's include human factors and ergonomics in the initial design.
Right.
And so I started looking for jobs that would allow me to do that. And then I found Lockheed Martin Space on the Orion program in Houston, working on the program. And I started that in 2017.
Well, yeah, and that's exciting because, we love space engineering here. We've done several podcasts and some coverage in the magazine on it. So we're really excited about that. I mean, the Orion project is so new. Artemis 1, we just saw the first test launch last year. Just give us an idea of some of the processes you work with, what your role is, and what does an ergonomist do in the design of a spacecraft and the systems that are involved with it?
Yes. Let's see where to start. In the beginning, as I onboarded and got familiar with the Orion program, I focused. Well, one of my areas was the hygiene bay, which you could think of as the bathroom. Mm-hmm. And as you can imagine many interesting conversations about how to use the bathroom in space or microgravity. So with that area of responsibility. So Orion program has been in existence for a while. So they had a lot of the initial designs determined. So it's more of a refinement, and we're starting to build more higher fidelity mock-ups because everybody understands the design and what we need. And a lot of like the structures were built and in place. So when I got into the role, it was more of the team, let me see how to set it up. So we have a team that is responsible for building the mock-ups. There is a medium fidelity mock-up of the Orion capsule and the Johnson Space Center mock-up facility. So you can go in there and get in the vehicle and see the crew module and all of the seats and all of the different pieces of hardware. And when you walk into the vehicle through the hatch, and you step down, the first thing you step on is potentially the exercise device, and then it'll be the door for the hygiene bay. So the hygiene bay is actually kind of a level underneath the cabin of where the crew will be living and doing different activities. It's not vertical, it's horizontal in that mock-up. Right. So we needed to create another mock-up so people can get in and stand vertically and be able to move around. And so when I got to the program, they were building that higher fidelity mock-up, and we wanted to refine the placements of the handholds and for using the toilet, or what's known as the Universal Waste Management System, UWMS. And then understanding, okay, we have the toilet design, higher fidelity, that was designed by another company. And then we have the different restraints and mobility aids. So now let's verify or start to verify the volume is appropriate for all types of astronauts, of all anthropometric measurements. And so a couple of things that came out of that is the foot restraint. Initially, the design was a foot strap. So the astronauts will come in and sit on the toilet, and they'll put their feet underneath the strap. And the idea was that they'll use, because you're in microgravity, you tend to just float up, right?
Sure.
And then with the foot strap, it's like, okay, they'll pull their feet against the top of the foot strap to be able to counteract the movement. But as we had more discussions with the astronauts and thinking about the design, we kind of moved more towards a foot plate so they can put the force downward as they're moving upward. So yeah, we have a handhold on the right side of the astronauts as they're sitting down, so they can hold on to that. And there are also tabs on the UWMS or the toilet, so they can kind of pull themselves down so they can have a good seal.
Yeah.
Because cleanliness is very important.
Yeah. Well, the kind of thing you don't think about when you're just sort of watching this from a distance. And you mentioned getting input from the astronauts too, and I imagine that's important. One of our speakers last year at the AEC was Nancy Curry-Gregg, a former space shuttle astronaut, and she talked about designing systems. Originally, the astronaut systems from NASA were not really designed with lots of different types of astronauts in mind. They were all designed for male astronauts of a certain physical size. It sounds like you're getting a lot more input and trying to create systems that work for all kinds of astronauts. Is that correct?
Very, very correct. Our requirements are to design from the 1st to 99th percentile. So the 1st percentile female to the 99th percentile male, which is everybody. The one thing that's interesting about being a human factors and human factors professional ergonomist is that for different anthropometric measurements, we have to go and find those people who have the desired measurements that we're seeking to get their feedback. And so I was fairly new to the company. And then in Houston, there's not a lot of engineers. There's a certain amount, as far as Lockheed Martin engineers. I can go on to NASA JSC and find a bunch of people where I was trying to find Lockheed Martin engineers. I will walk around the office kind of looking at people's calf lengths because we're sitting on the toilet and having a foot plate. We have to understand with people with shorter calf lengths, how tall do we need to make the foot plate off the ground so it can support their hip angle. If you could think about the squatty potty, when you're doing that task, you want to have that good hip angle. And so I had to walk around the office and I'm like, you have a shorter calf length. Would you be interested in participating in this evaluation?
Yeah.
So I would go out and so as the design iteration process matures, we tend to start off with engineering subjects because the astronauts are extremely busy supporting multiple programs. So we'll start off with the engineering subjects, get their initial input and start to mature the design. And then we'll go and ask the astronauts to come in and get their feedback. And then we'll collect all the data and provide that to the designer so they can iterate on a design and incorporate that feedback. But so with the foot plate, we definitely had to get female astronauts and female engineering subjects because of that anthropometric measurement we were looking for as far as the calf length to be able to bring their hips up to a proper angle.
Yeah, and now there are so many more female astronauts that it was a novelty at one time back when Nancy first started. So certainly diversifying all the systems is very important. How much too do you factor in? And I think she touched on this too. As an ergonomic designer, you have to think about the cognitive overload that astronauts may have. They have a lot of data coming in from a lot of different systems when they're operating the spacecraft. How much of that do you have to factor in to make sure that they can handle all of this and run those systems efficiently?
Yeah, so that speaks to the other area that I cover, the displays and control system. Mm-hmm. And with that, understanding that there is a lot of information that the vehicle provides and that we can show to the crew. But the question that the team, we always ask ourselves, what can the crew do with this information? What action will the crew take knowing this information? And we, the things that I was responsible for were in the beginning, because I didn't necessarily have a lot of user experience or UX design experience. I would lead what we call rapid evaluations, which would be the initial quick look. This is the layout. This is the use of color. This is the text. This is the purpose of the display format, which you could think of like a website, and then get the crew feedback on, okay, what do y'all think of this initial design of the display? And with that is just more verbal feedback rating. And so that'll be our initial evaluation. And then we'll have a second type of evaluation where it's more scenario based, where we're integrating the different displays for different subsystems, and then also the electronic procedure system. Back on shuttle and many other vehicles, they had paper procedures, thick books of paper. Yeah. Now it's all electronic.
Sure.
And with those scenario-based evaluations, we will capture the Bedford workload rating for their primary task, how much spare capacity is available for their secondary task. And understanding with all this information on the display in the electronic procedure system, what is that spare capacity for them to complete their task? And we do have two requirements for the Bedford workload rating. One for nominal tasks, so expected tasks, for example, entry, landing, descent. So when they're coming back to Earth, we have it for launch. So whether they're strapped down and just holding on for dear life, for that scenario. And then we have, so for that, the ratings should be a 3 or less, which is they have enough spare capacity to complete these nominal tasks. And then for off-nominal scenarios, so maybe emergency cabin leak, where we're verifying against that scenario to say, okay, this is not expected, but it could happen. What will be the mental workload and spare capacity for the astronauts in that scenario? So we'll have the caution and warning alarms going off. We'll have the emergency response system going off, and they will have to respond to the system and work through the electronic procedures to understand the tasks they need to do to resolve and troubleshoot what's going on. And then at the end of that scenario, we take the Bedford workload rating to understand that's mental spare capacity that they have available following that task. So it's very important, and we do it throughout our development, and we'll do it for our verification of the system.
Yeah, and I guess you do a lot of modeling and testing of that as you go along too, just to make sure that kind of system overload doesn't occur when they're trying to handle these things.
Correct. Yes, we've done a lot of evaluations for not just the display and control emergency or off-nominal scenarios, but also for within the cabin vehicle itself. For example, emergency egress, so leaving out of the vehicle quickly on the launch pad. We've done a lot of verification integrated with the astronauts as well as the exploration ground support system team, the EGS team, that will help get the astronauts strapped down in their suits before they launch. So we've done a lot of testing for all types of different off-nominal emergency scenarios to ensure that with everything going on, does the crew have the mental capacity and spare capacity to complete those tasks safely?
The first Artemis 1 mission that was launched last fall, which turned out to be very successful. I imagine everyone's pretty happy with the way Orion performed on that, because it all seemed to go very well. There were mannequins instead of astronauts involved in this mission, collecting data that I imagine would be of use to you and your team in terms of how those mannequins handled certain pressures or G-force or whatever. What sort of data did you get from that, and how do you use all that as you go forward with the next mission?
Yes. So I know there is somebody on our team who works with the system dynamics. So looking at more of the biomechanics of the vehicle. So looking at the vibration of the seats and getting, like you said, the mannequins, they had different sensors on the mannequins to collect that vibration data to understand what will be the effect of it. Because we've done a lot of testing and we have a lot of models to say what the vibration we expect to be, but getting the actual data and understanding what it will mean and feeding that back into our design, if necessary, just depending on the deltas, is something that we're looking forward to. I necessarily don't work with it, but I think one piece of data that I am kind of involved in is the vibration of the display units and how much that may affect the visual aspect of the information on the display of, okay, during certain times of the mission, we understand the vibration, the G loads will be higher. How does that affect the display units? And does it shake with the display formats, causing the information to be blurry, or what would that look like? Right. And do we need to incorporate that into our verification test as a way to test like you fly? So we expect it in flight. We want to make sure we incorporate that in our tests. So we're excited to get that information back to see what we need to do to make sure we're preparing and verifying the vehicle as it's designed and we understand the design to be.
And the Artemis 2 mission, which I think right now is tentatively scheduled for next year, is actually going to include astronauts in an orbit around the moon. And that, I imagine, would be your opportunity to really see how all the systems, how the astronauts handle all the systems in place and how you fine tune that. You must really be ramping up at this point, preparing for actual human astronauts to be in the capsule on a mission for the first time. That's got to be really important data going forward, I would imagine.
Yes. So actually the work is ramping down, where if the program lifecycle, we're more towards, so the program lifecycle is design, integration, test, and verification. So with the hardware, we're more in the verification. So all the designs are mostly complete, and we're verifying to requirements, like, yes, we designed it to meet the requirements. But for software, we're more of the integration and test phase. And with that, I'm responsible for leading the verification activity of the display and control system. So understanding the integration of what we call display formats and then the software code behind it, and then integrating that with the actual display unit hardware and testing that in the lab environment. As I was speaking earlier, we'll have different scenarios that we want to verify against. So the nominal scenarios of launch, landing, off nominal scenarios such as cabin leak. We have electrical failure that we want the crew to troubleshoot to say, if these types of scenarios occur on the mission, then we're verifying the workload, the error rate. And so my job is to coordinate with all the different teams on the NASA side, the Lockheed Martin software side, the lab side of, okay, we got to bring it all together. How we're going to test the system as flight-like as possible to get those requirements verified to say, yes, we built a good, safe display and control system. And so that verification, it should be going on later this summer and for the rest of the year. So it's exciting to finally get all the pieces together in the high fidelity lab to see how do we do and then getting that feedback from the crew. But as I say, we've done a lot of tests, so we have a good idea. But it's just getting those fine-tuned pieces together of understanding what it looks like in the higher fidelity lab. Well,
turn back to the conference a little bit. I mean, are these some of the topics you plan to discuss in your keynote? What just a little sneak peek? We don't want to give it all away, but what items in particular do you want to highlight for the group there?
It's going to be mostly about my career journey, like I was speaking to earlier, but I'll touch more of the how and why I made certain decisions, because I realized everything was done intentionally, even though it didn't feel like it at the time. All the internships and co-ops and what I've been studying and the jobs I've been choosing and how I've been networking with people. So I'll be talking about the intentionality of experiences that I had and the connections I've made, and just helping people understand, or talking about how I'm starting to infuse things in my personal life to help me with my professional development. For example, I enjoy comedy a lot. I like to go to improv shows and watch stand-up shows. And I took an improv class in 2021. And with that, I learned the yes and. And that concept is about not interrupting the creative process. So when somebody is given an idea, you don't depending on the idea itself and how you feel about it, you don't want to just say no and cut off the flow of creativity or just let it come to an end. You affirm it saying yes, and then you add whatever you want to add to it. So yes, and let's do this, this, and that. So I realized that's very important. And we, as human factors and ergonomic professionals, we do that all the time. We're working with creatives, the designers, people who are coming up with these ideas, designing the hardware and the equipment. They're creating things, and we don't want to disrupt that creative flow. Yeah. So affirming and then adding what we think as far as from the human factors lens, yes, and let's make sure we meet the requirements, or we make sure that all people can leverage this system and use it safely and efficiently. So that's one thing I'll be talking about. And then on the personal, so that's more like the professional side. And on a personal side, just talking big picture of coming out of school, I had a slight idea of what I wanted to do, but it didn't encompass like my full life. It's like, okay, I want to do this for at least these amount of years, but I didn't think about what I would want to do afterwards. And so I want to give people the opportunity, or talk about, so let's put yourself in the seat of you're at the end of your life, however old you want to be, however you want to envision yourself, of good health, being surrounded by good people, being surrounded with happiness and joy, whatever you want to be surrounded by. And you're talking about your successes in life, whether it be a personal success, a professional success, or a combination of both. What would you want to tell people about your success in life? What would you attribute to your success? And just having people think about that, because I believe it'll help you with your day-to-day decisions and be more present as like a North Star of, okay, I say that one thing I want to tell people that contribute to my success is that I committed to doing what I know I need to do. So as I'm living my life, I can ask myself, okay, am I committing to knowing what I need to do? And if it's no, then I know it's not taking me toward that destiny of what I want to tell people, how I obtain my success.
And as part of that, you do mentoring with young folks too, and activities to help get young students involved in STEM studies and engineering fields. And they must see someone like yourself, especially a young girl who might want to get into engineering, as kind of an example of what can be achieved. That's something that's important to you too, right?
Oh, yes, definitely. Definitely. I've gone back to my high school for career day. And funny enough, the career day that I attended, there were two other people that worked in aerospace. So one lady, she was working at Stennis on the NASA side. And I think another lady was working at Boeing on the SLS rocket. So that during that time, they had three people working in aerospace and just talking about our different experiences, all related to the Artemis mission. And so I enjoy doing that. I've done a lot of speaking engagements, representing Lockheed Martin, talking about the Artemis 1 mission, but through the lens of human factors. I've done speaking engagements for college students, middle school students, elementary school. I was a part of the Project Anos video series, or an education initiative that is showing students about, just telling them about different subject matter experts working in space exploration. So I've been able to participate and give that human factors point of view, because I personally love human factors and ergonomics. I believe everybody should learn about it, because I realized that you can learn about yourself learning about human factors and how you operate in the world, and kind of the why behind things that you see, like why something is designed with a certain color or why something is designed with a certain shape. And then you can understand how to interact with it because of that design.
Yeah.
But so I've been doing a lot of speaking engagement with the youth and just showing them as an example of what you could possibly do in human factors in the space industry. I've been involved with the National Science Foundation and their I-Core program, which is an entrepreneurship training program for there's two aspects to it. There's like from the university researcher side, so allowing them to test out their idea to see if there is a market for it. Because a lot of people are doing a lot of good research, but sometimes they get stuck in the university world and it doesn't get introduced to the market as a product or a service that can be beneficial. So helping the researchers, from my perspective, understanding the industry and what businesses look for, understanding the supply chain, the quality and manufacturing aspects of it. So I should serve as an industry mentor for that program. And then I do want to get into coaching and more mentoring one-on-one with different students, just to give them a space to think about their full life and understanding they may change, which is fine. And just giving them space to say, okay, in 20 years, I might want to do this as far as personal and professionally.
And ergonomics, like you said, it's sort of inspired you because it's something you can see the effect of on people. It's yes. Not just a theory on a blackboard or an algorithm. It's something that you can actually get your hands on. Have you been to Applied Ergonomics Conference before? Have you attended in the past, or
yes.
Is this going to be for? Yeah. How many times have you gone?
At least 3. Story time, if I may. The first time I attended the AEC was in either Nashville or Orlando. It was soon after I accepted my full-time offer at Michelin. Mm-hmm. And then at the time, Dr. Bobby Watts, she also accepted a full-time role at Michelin. So I met her at the conference and I'm like, oh, we're starting together. And she's the North American ergonomic program lead for Michelin. And then I also met my other ergonomist colleagues at the conference. Mm-hmm. So like, okay, I got this new job and I'm meeting all the people I might work with. I'm like, oh, this is pretty cool. Yeah. And then I volunteered for the social media committee. And so I worked on the social media committee for a couple of years. Dr. Bobby Watts is my mentor and she encourages me and she brings me to the different conferences as a co-presenter on different presentations. So I've presented at the AEC a couple of times. And then most recently, the past couple of years, I was a part of the strategic planning committee, working with a lot of the good folks on the AEC board, just to talk about the future of the conference, given all the technological advances with Zoom and being virtual for the conferences. And so I've been pretty involved with the AEC.
Yeah. Well, I mean, we know Bobby Watts well. She's a frequent guest on our podcast before. She was actually a host for us once. She's the incoming president of the Applied Ergonomics Society. So she's very involved in all of that. We look forward to seeing her. What advantage do you get, though, just being able to go and network with all your fellow ergonomic professionals? This is the one chance you guys all get together. And after a couple of years of the pandemic, when we were all doing this online, it's got to be great to be able to just touch base with those folks, right? Yes.
It's really getting re-energized of the why behind what we do in our profession, because as I was speaking earlier, sometimes you may get defeated with trying to implement change and improvement when you're meeting resistance. So it's like, oh, why am I doing this? I feel like I'm hitting a brick wall. But when you get around others who are in that space, we uplift each other and help us refocus on the why and how we're helping people improve their lives and work safely. And so just being around that, it gets me excited about what I'm doing and why I'm doing it.
Well, and you're a New Orleans native, so we're going to be down there. And I made my first trip there last year and fell in love with the place in just a few days. But give us an idea. What should everybody make sure they have just a little bit of time to go visit somewhere in town? Where should they go? What's the one place or one or two places people should hit real quick when they're there?
Oh, that's always tough because I left when I was 18 and I didn't really turn back. So my experiences are not of what people experience as adults. Let's see. But definitely the French Quarter, just getting that vibe and just seeing how easy it is to have fun when you're around good people. it doesn't take much to have a good time in New Orleans. Frenchman Street. Well, I think that's where a lot of the locals go, and you see live music. So if you love music, that's the area for you to go. If you just want to learn about New Orleans, there's swamp tours and seeing those types of areas that you may not see if you're from a different state. A lot of museums in that area, in that downtown area. So it wouldn't be far from the conference that you can just go walk or take a Uber to.
Yeah, we went to the World War II Museum, which is really great, just a few blocks away. And you got to get the beignet at the Café du Monde too. That's a requirement. Yes. So, well, we really look forward to it, Lashawn. We appreciate your time. We look forward to seeing you there and listening to your keynote. It's been great listening about your career. We look forward to learning more. We look forward to everybody being at AEC, and hope you have a great experience there. We look forward to seeing New Orleans and hoping to touch base with everybody after a year away.
Yes, it'll be a good time. Thank you, Keith. I enjoyed myself.
Thank you.
You've been listening to Problem Solved, the IISE podcast, a production of the Institute of Industrial and Systems Engineers in Norcross, Georgia. We hope you'll share this and other Problem Solved episodes with your friends and colleagues. Learn more about sponsorship and advertising opportunities, as well as how you can become a member of IISE by visiting podcast.iise.org.